Well, regarding the acidification of the oceans, if that is what you'd like to hear about, we are hearing that a drop in pH, that is the acidity of the oceans, is of the order of 0.1 unit. And then the question is now, what is natural?
Which means that the oceans are becoming more acidic.
That is what we are being told. Then the question is, what is the natural range of pH in the ocean? And I was showing the pH measurements from the Western Pacific, which is varying from about 7.5 to 8.2, 8.3. And the question is a change of 0.1 really significant? And I will say, no, it is not really. And then we can say, well, where do we find the lowest values in the Pacific Ocean? We find these in the cold climates. Then the thing is that colder water has a lower pH than warmer water. If you have an upwelling of cold water, of course you will measure a lower pH, but that has nothing to do with the anthropogenic addition of CO2 to the atmosphere. Then what they have forgotten is to look at the buffers in the oceans. And buffers are chemical reactions that are making the pH constant.
Like neutralize the acid.
Yeah, exactly like you buy buffer solutions for your laboratory, you buy that for your aquarium, whatever. And what happens is that we have the calcium carbonate in the sea. If you add more acid to the sea, it will immediately be neutralized by the calcium carbonate in the sea. We have a number of other buffer systems. We have an anorthite kaolinite buffer. We have clay mineral buffers. We have a calcium carbonate, calcium silicate buffer, and they all add to what Stam and Morgan in their authoritative textbook on aquatic chemistry says is an infinite buffer capacity in the sea.
So that means that no matter how much CO2 we emit in the air, the ocean acidity will never become a problem.
No, it will not, and we can see that throughout the Earth history that we have not seen any change in the corals or in the calcareous organisms. That's why we find fossils preserved made out of calcium carbonate, because they have survived the additions of acid from volcanoes. They have survived the addition of acidic precipitation, acid rain, for many, many years. The water itself in the rain droplets has a pH of about 5.5. And it rains and it rains and it rains with pH 5.5, but still the ocean is about pH 8. So these buffer reactions, they work all the time.
But where does this fear for acidification of the oceans then come from? These are all scientists, they know what they're talking about.
Well, a scientist is a scientist is a scientist, you may say, but the chief ideologist here is Ken Caldeira in Washington. He is a global ecologist, he calls himself. His papers don't contain anything in terms of chemistry or thermodynamics. Those are the tools I play with in geochemistry. So the global ecologist is not playing the game with the tools that I'm playing with.
Are there any signals from the animal or plant world that the oceans are becoming too acidic?
Well, we haven't seen any that can be connected to a change in acidification of the oceans. But I'm, again, not a global ecologist. I'm a geochemist, so I can look at the pH and the buffering of the minerals because these things have not been considered by the alarmists on the acidification of the ocean.
But as far as you are concerned, acidification of the ocean is a non-problem.
It is a non-problem if looking at the real ocean, which contains the salt, which contains the minerals there, but the ocean of the IPCC, the International Panel on Climate Change, they consider the ocean as distilled water, and everybody who has tasted the seawater will say that this is not so.
Thank you.